This is a video about how I design fluid responsive websites in Figma. I call this kind of design Utopian design. If you've never heard of that, you might want to watch the Utopia intro video first, which covers the context and concepts of this approach. This video does assume some understanding of that as well as some familiarity with Figma. This video is a walkthrough of a file I published to Figma community called Utopian Project Kickstarter with Modes. While everything here can be achieved in stock Figma without running any plugins, this approach does require Figma variable modes, which is a paid feature. There's nothing to stop you designing a Utopian website in the free version of Figma, or any other design tool, but variable modes transform the way I work and have become essential to my way of working. The link to the Figma file is in the video description. The original version of this file, created before Figma introduced modes, is still available from Figma community, but I don't use or update that version anymore. We've also designed a couple of Figma plugins which massively speed up the early steps of this design process. I plan to make a separate video showing how to use the plugins to quickly customize this Kickstarter file. I use this file to start practically every web design project these days because it lets me skip lots of repetitive tasks, which mostly relate to things like setting up foundational elements and common components. There are plenty of huge UI kits out there, but I'm not looking for someone else to do the design work for me. I'm just trying to skip the blank canvas stage and start producing something useful as soon as possible. A crucial difference between this file and other starter kits is that this one's geared not towards responsive design, but fluid responsive design specifically. That distinction is more significant than it might sound. Because a Figma frame doesn't yet behave like a browser viewport, we still have to design multiple views of each component. That used to mean designing for a random assortment of breakpoints like mobile-ish, portrait tablet-ish, landscape tablet-ish, laptop-ish, desktop-ish, etc. Utopian design is as device agnostic as possible, which is why we talk about viewport size and not device types. We usually only need to design Utopian components for two viewport sizes, a nominated minimum and maximum size. So in this file you'll find at most two versions of each component, labelled min or max. Since Figma introduced modes, we only need a single version of some components because all of their responsive properties can be set with variables. However, it can be helpful to show both min and max versions for quick visual reference. The reason I made this file is because over the years I found myself either recreating the same components across a lot of projects, or cannibalizing old projects which might have been constructed or organized in ways I'd now consider dated. So I try to keep this file up to date with my most commonly used components and the latest ways of working in Figma. The Utopian Project Kickstarter file currently has 5 pages: demo page designs, components, foundations, readme, and meta components. This file evolves constantly though, so your copy might look a bit different. Page layouts and components. Let's work backwards from these layouts pieced together using Utopian components. These 2 pages represent a single page design shown at each end of our viewport range. On the surface, these demo pages look pretty basic. It's the way they've been constructed that's interesting. The elements and styling in this file are intentionally minimal. Utopia doesn't dictate any particular visual style. The idea is that for each new project, the designer will replace the colors, type and space size values, fonts and styles with whatever makes sense for the project at hand. There are some examples of Utopian sites on our showcase page if you want to see what other people have come up with. Long story short, Utopia doesn't look like anything. It's up to you to bring your own design flair. This simple page design includes common components like a breadcrumb, some headings, lead copy, body copy, an image with a caption, a list, and a pull quote. This is just a small selection of the components in this file. If we select one of these components and click to go to the main component, we're taken to the components page, and the main or source version of this component is selected. You can see the other text components here in the same frame. What's interesting here is that the components in the min and max columns below are instances of the same source component. The differences are purely down to the mode applied to each column. The majority of components in this file work in a similar way. This file includes some essential atoms like icons, links, buttons, and inputs, as well as styles for tabs, accordions, tables, alerts, text callouts, and simple cards. These are the basic building blocks of the majority of websites we work on, and having them already set up like this, ready to restyle, really speeds things up. There are also a few slats for convenience, including a site header and footer, and a simple hero. These slats usually get replaced, but I've included them to help put together really quick wireframes. This collection of simple components removes a lot of repetitive work at the start of most projects, and means we can spend more time thinking about more interesting, client-specific problems. So far, this is a pretty typical starter kit, a bunch of minimally styled components ready to be branded and organized into a useful website design. It's at the foundation level where things get a bit different. Foundations. This is the Foundations page, a visualization of the styles and values that underpin our components and page designs, including color, space, and type. The values represented on this page are stored and tokenized in the Figma file's variables. These are just pictures of those design decisions. If we look at the file's variables, we find all the corresponding values defined. Utopian design is systematic because it's based on sets of related values. The Kickstarter file uses values that we consider sensible defaults, but you can change these to suit your project. We visualize our foundations as 3 palettes: color, space, and type, which we then use to paint the content of a website into the viewport. Utopia is about type and space, so I won't go into detail about color in this video, except to say that on virtually every project these colors get completely refactored. What you see here is just enough organization to style the components that come with this file. It's also set up in a way that colors can be replaced to get the file looking brand appropriate really quickly. Type. The type palette shows a matrix of sizes and styles. Each size is defined as a step, and the sizes are based on our type scale. The scale starts at step 0, which is our project's body text size. Each time we step up or down from step 0, the size increases or decreases by the multiplier we've chosen for our type scale. If your scale multiplier is 1.2, and your step 0 size is 18 pixels, your step 1 size will be 21.6 pixels, step 2 will be 25.92 pixels, and so on. That's nothing new to designers. Utopia didn't invent the concept of typographic scales. What Utopia brings is the possibility for 2 type scales to gradually morph between each other while factoring in the current viewport size. A crucial part of Utopia is that our min and max designs share the same tokens, and these tokens have responsive behavior encoded within them. In a browser, type sizes can be calculated with CSS, based on our chosen step 0 size and type scale multiplier. In Figma, we have to hard code these values. It's not ideal, but it's still more efficient than the breakpoint-based method, because there are far fewer variables to declare, and that's because we're dealing with 2 viewport sizes instead of 4 or 5 breakpoints. To demonstrate how Utopia uses a single dynamic value for each of its tokens, take a look at these 2 versions of the type palette. We can see in the layers sidebar that the left-hand version is a source component, and the right-hand version is an instance of that same component. The only difference is that the right version has the max mode applied. To prove it, let's delete the max instance and create a new copy of the component. When we change the mode, we're simulating resizing the viewport. We can see it's the same component, using the same variables with different values assigned to each mode. This is how most of the components in this file have been designed. Take this USP component, for example. The top version is the main or source component, the middle is the min viewport version, and the bottom is the max viewport version. Main and min are identical, because min is the default mode in this Figma file, so the variables haven't been changed. In the max version, we can see that the text is a bit bigger. If we select the heading in the source version, we see the font size is step 2. If we select the heading in the min and the max versions, we see they're all using the same token, and it's the token that's responsible for displaying the correct font size. We can inspect any of the text in any of the components in this file and find they all refer to one of our predefined steps. Space. In a Utopian design, spacing works similarly to type. Here we have a number of space palette frames showing min and max values for individual space units, space pairs, and custom space pairs. If these look empty, try toggling Figma's layout grid with Shift and G. You should see these piles of squares. Each frame lists the values for our default space tokens, including the multiplier, the pixel size, the t-shirt size, and a visual representation of each value as a purple square. The Figma plugin called Utopia Fluid Type and Space Calculator will attempt to update these frames to show your chosen values, or you can update them manually. These frames are for visual reference to show what's going on behind the scenes. Space can be tricky to visualize within our designs, and this is one way to document what's going on. The top row shows the 1x or small value, which matches our body or step 0 type size value. The default step 0 value scales smoothly from 18 pixels at min to 20 pixels at max. The other sizes are all multiples of that core value. In a Utopian project, every space token is fluid. For example, 2xl is a single token which has a value of 72 pixels at min, 80 pixels at max, and a calculated value at any viewport size in between. Remember, these frames are just a visualization of some of our design decisions. The values themselves are stored in Figma's variables. We declare our basic space values in the variable collection called space primitives, divided into min and max groups. Each of these is our step 0 size multiplied by various numbers and given a t-shirt size name, like small, medium, or large. Unlike type, there's no fixed multiplier. We find this approach easier to work with for space values, and we deliberately use different naming conventions for type and space to avoid confusion. In the variable collection called fluid tokens, the group called space size connects the primitive values together. Here along the top we have min and max modes, and each space token is given 2 values. If I hover over these, we can see that 4xl has a value of 144 pixels in min mode and 160 pixels in max mode. Back at the USP component, let's check our spacing. The auto layout gap defined here is using the small token. Notice there's no mention here of min or max. We want to pick our size from the fluid tokens collection, not the space primitives collection. In a min context, or in other words inside a frame with the min mode applied, the small or S token has a value of 18 pixels. In a max context, the same S token has a value of 20 pixels. Similarly, the gap between the heading and the body uses the 2xS token, which has a min value of 9 pixels and a max value of 10 pixels. As a bonus, the icon's size is also defined by the large token. Once you establish these fluid values, you can use them in lots of different ways. In a browser, this entire component will gently breathe into viewport space as it becomes available. In theory, the developer of this component wouldn't even need to see the max version in design, because everything about its responsive behavior is encoded in the tokens it uses. Shown in isolation like this, the type and space scaling of this USP component is subtle. The effects are amplified when every component on a page behaves this way, or when space pairs are used. Space pairs and custom space pairs. To achieve more dramatic space scaling, we can use space pairs. These are tokens whose values flex from one t-shirt size to another, like small to medium or large to extra large. In this site footer design, the top and bottom padding uses a token called XL to 2XL. Instead of scaling from the min XL value to the max XL value, it scales from the min XL value to the max 2XL value. This is useful when we want a particular space in our design to scale more between our min and max viewports. The Utopia space calculator automatically calculates these single step pairs for you. It also lets you add your own custom space pairs. This is how you can add tokens which can scale from any size to any other size. For example, here in the layout grid, we're using a small to large token for the gutter spacing. If a designer uses this token set consistently, a developer could already know how this space should behave in any viewport, without needing to see designs for specific screen sizes. Layout grid. There's a link in the description to an article about how to design a fluid responsive grid. This kind of elastic stretching is what we're aiming for. The default layout grid in this file has 12 columns and uses a small to large custom space pair for the gutters. The columns equally share any space that's left over, but because we don't usually want our grid to keep growing forever, we give them a max width of 2XL. In other words, when space is no longer a constraint, we can choose both the gutter size and the column size. You can stick with these defaults, or you can design your own grid, with any number of columns and whichever space tokens work best for your content and style. There are various ways to build a grid like this in code, but those implementation details are outside the scope of Utopia. I've included a variable set called grid, with named values for things like gutter and common column divisions. These are all based on our space primitives. This lets us encode responsive behavior not just within components, but also into whole page layouts. Because this demo page has been built using our components, and our components have been built using our foundations, and our foundations have been built using fluid responsive properties, we can view our min and max versions in a single frame, just by switching its mode. Switching the frame's mode between min and max simulates changing the size of the viewport in a browser. This is all made possible thanks to variables, modes, and some thoughtful organization. Wrap up. Utopia is a systematic approach to fluid responsive design. It encourages us to consider relationships between elements as well as their internal features. When we think about a design in terms of related properties on a kind of macro level, we can allow the system we're building to start guiding and speeding up our micro design decisions. If our body text size is step 0 and our H1 heading size is step 4, we have 3 options in between for our H2 size. If none of those options are quite right, we can adjust our typescale multiplier to create an appropriate step size for our H2. But because the system is interconnected, we need to consider the impact that change will have on our other components, including the original step 4 size we were happily using for our H1. To find the right balance, the options you can play with are the body text size, the typescale multiplier, and the number of steps. You can also skip steps in your scale if you don't need them, but remember to consider min and max if you do that. This balancing act is where designers can find Utopia unintuitive. Ordinarily, they could just pick any size they want for an H2, using their professional taste and judgment. In a Utopian design, no decision is made in isolation. That's why when we want to fine-tune our scales, we go back to the calculators on the website to rebalance the whole system, rather than overriding individual values here and there in Figma. By considering our min and max designs simultaneously, we're still using our taste and judgment, but in a more powerful, joined-up way. By practicing this holistic way of working, every designer and developer working on a product can stay in tune by knowing a few key numbers. Every member of your design orchestra will know which key to play in. As your system's rules emerge, you can design and build faster and faster with fewer mockups and less CSS required. And the fluid responsive behavior is already baked in, so your designs will look right in any browser. I know it can be hard to grasp some of this at first, but when it clicks, it's like seeing the Matrix. I hope this video makes sense, and I hope it encourages a few people to give Utopian design a go.